Hello, everybody listening on Facebook and YouTube. I'm Dan English, the program coordinator for the Missouri Local Science Engagement Network. That is part of the MOST Policy Initiative, and we are here to discuss everything neuroscience. But before I get to that, I want to tell you all about our next event about science and the law. Learn how science is used in the judicial system and what it takes to be an expert witness. You can sign up for that by going to mostpolicyinitiative.org under the tab Local Science Engagement Network. Give that a click. There's a drop-down menu, and you can find the live event from there. So without any further delay, let's welcome in Dr. Josh Mueller from MOST. Dr. Josh Mueller, how are you doing today?
I'm great. How are you, Dan?
Pretty good. Let's talk about also our next event coming up, which is all about vaccine hesitancy in rural Missouri. We've got a couple of great guests lined up for that, don't we, Josh?
We do, yeah. We're hoping to have a bit of a community discussion here about an angle that I think if people follow the news around vaccination, they've seen a little bit, which is that in some more conservative and religious and rural communities, there are expressions of concern around this really new technology, something that we maybe don't know what the long-term effects are yet. And so we want to get some experts in the state and some people with some credibility in those communities to talk about what they're hearing and how they talk about those issues to make sure that people are getting accurate information and aren't being scared away from what we know is a really important public health measure.
Mm-hmm. And we've got some absolute rock star level guests coming from UMKC and the Missouri Foundation for Health. Let's introduce almost doctor, almost PhD, soon to come, days away, Hannah Fry from Washington University. Almost Dr.
Hi.
Fry, how are you doing today?
I'm good, thank you. Yeah, like Dan mentioned, my name's Hannah Fry. I'm a graduate student at Washington University in St. Louis in the lab of Dr. Jose Moron Concepcion in our anesthesiology department. And my line of work mostly focuses on substance use disorders such as opioid use disorder and how pain and memory can all intersect to put people at risk of developing opioid addiction disorders. So thank you very much. Glad to be here.
Very good. Very good. Hey, I'm only going to pop up in this discussion when I need to, because, those two over there are the neuroscience experts. So I will let them introduce everybody in the neuroscience field. And my dogs are going nuts anyway. So if you have any questions or comments, get down into the comment section and write your comments there. We'll get to them. Sometimes there's a 30-second delay in between when you type it and when our eyes see it. So just be patient. We'll get to them. Anyway, guys, I'll see you in a bit.
Great, thanks, Dan. Well, as you're running the show behind the scenes here, I'll take a second to introduce our guest today. We've got a really great panel, a wide variety of topics. As we were trying to figure out who to ask to talk, it was really a challenge because I think, in my opinion, and Hannah's opinion, neuroscience touches almost every aspect of our lives. So that made it easy in one sense, but also hard. So I want to introduce Dr. Elena Baker-Nye, who's assistant professor in biology at St. Louis University. Hi, Dr. Baker-Nye. Can you tell us maybe a little bit where you are right now and a little bit about your research?
Yeah, thanks, Josh. I'm Dr. Baker-Nye. I teach in the biology department and also in our undergraduate program for neuroscience at SLU, St. Louis University. So I am in St. Louis and actually a St. Louis native, so that's kind of nice for me. And yeah, my research background is in Alzheimer's disease specifically. So I've done about a decade of work in that field, starting off in graduate school looking at cell types that are selectively vulnerable to the disease state. And then a postdoc at Washington University looking at human biomarkers for Alzheimer's disease, and specifically trying to track the production and degradation rate of apolipoprotein E, which is a significant genetic risk factor for Alzheimer's disease. So I was in that field for the better part of a decade, and sort of ate, breathed, and slept nothing but Alzheimer's disease during that time. So happy to answer any questions about the pathophysiology or cognition or symptoms that folks have.
Great, thank you so much. And I know that this is a topic, and many of the other topics we're going to discuss today are near and dear to the hearts of many of the viewers. So we just want to remind everyone that if you have questions, feel free to drop them in the chat of whatever platform you're viewing on, and then Dan will pop in to relay that information to us. So next up, we've got Dr. Fred Rodnick. Hi, Dr. Rodnick. Maybe you could do the same brief introduction for yourself here for everyone watching.
Sure. Hi, I'm Fred Rodnick, family physician and addiction medicine doc at St. Louis U, director of community medicine. I'm also director of our new addiction medicine fellowship, first and only in the state of Missouri as of right now. I'll see if I can change that. My clinical work has been homeless work, correctional health care, and addiction medicine. And I work with the state opioid response, and I also work with Assisted Recovery Centers of America.
Great, thanks, Dr. Rodnick. And now rounding out our St. Louis contingent here, we've got Dr. Tony Buchanan. Hi, Dr. Buchanan.
Hi. Thanks
How are
for
you?
having me on. I'm doing all right.
Great. You mind telling us a little bit about your background research as well?
Yeah, sure. So my lab studies stress and its effects on brain and behavior. So broadly speaking, how does stress influence the way that our brains function in terms of learning, memory, and decision making, and with a special emphasis on decision making related to addiction. So why do people decide to take drugs or to gamble too much? And so we're interested in the impact that stress can have on those particular decisions that people make, oftentimes to their detriment.
Great, thanks so much. We've got another guest here that I know, Hannah, you know fairly well, so maybe you can introduce Dr. Eversdorf for us.
Yeah, so I'm happy to introduce Dr. David Eversdorf at Missouri University, and it'd be great if you could tell us a little bit about some of the work you do.
At first, I wanted to compliment Tony Buchanan on his awesome A-frame in the background. I am I'm trained as a cognitive behavioral neurologist, but I'm a professor of radiology, neurology, and psychological sciences at the University of Missouri and the William and Nancy Thompson Endowed Chair in Radiology. I actually started my career looking at the pharmacology of the effects of stress on cognition. So I've had numerous conversations with Tony, but my emphasis has been more on problem solving and that aspect of things. And this pharmacological model actually led me into working with autism. I was already working with autism, and we've been just completed a large clinical trial to look at anxiolytic in autism and its possible effects on social behavior. I've also become interested in the effects of stress on development and subtyping of autism in a meaningful manner, because that's a critically important issue. And I'm also involved with markers for autism, markers for dementia, because the cognitive behavioral neurology is my ends up being kind of my home turf, and I'm helping the University of Missouri facilitate the development of an Alzheimer's center, or at least that's the plan. And I've also worked with Hannah Fry rather extensively with government advocacy for research, because it's important that our policymakers understand what the heck we do and why.
Great, thanks so much. And last but not least, rounding out our panel, we've got Dr. Amber Abernathy from Missouri State University. Hi, Dr. Abernathy, how are you? I believe you're on mute right now.
How about now?
Perfect.
I'm doing good.
Great. Well, if you wouldn't mind telling us a little bit about your research, and then we can get into some free-flowing discussion here, maybe.
Yeah, so I am an associate professor of psychology at Missouri State University. I'm also the Mary Charlotte Bell Sheely Chair of Conscientious Psychology, mouthful. So I study personality and conscientiousness. I looked at some stress responses as well. I do some physiological data with skin conductance and saliva. And then more recently, I'm looking at adverse trauma in childhood and how that might affect adult outcomes, relationships, resiliency, and the factors that affect that.
Great, thanks so much. Well, now that we've got everyone gathered here, we'll kick off sort of our line of questioning. As you all heard, we've got quite a variety of topics on hand today. So we're hoping to sort of turn things over. We'll give a little bit of guidance in terms of questions, but we really encourage you to jump in if something grabs your attention, or if you have something in your work that relates to what the topic of discussion is. So I wanted to start off, I guess, as a brief introduction as well. My background is in computational neuroscience. I received my PhD from the University of California, Santa Barbara, but I'm now working as the Health and Mental Health Policy Fellow for MOST. So transitioning into the policy world a little bit, following all sorts of legislation moving through the General Assembly this year. And one thing that we've heard a lot about, it's got a lot of attention, a lot of movement, and a lot of legislators interested in it, are issues around early childhood development. So whether that's elementary school or child care facilities or child tax credits, there's a lot of attention being paid to how important the early childhood stage is for healthy development later in life. So I wanted to open this up, maybe start with Dr. Eversdorf. Can you tell us a little bit, I know that a lot of your research is centered around maybe atypical neurodevelopment, but could you tell us what we know broadly maybe about just the importance of early childhood development? What sort of factors do we know are either risk factors or positive elements in allowing children to develop healthily during early childhood?
Well, as you stated, I'm a little more involved in aberrations of development, and often in the prenatal and genetic environment as the critical factors there. But we do know for sure that environmental enrichment definitely has an enhancing effect in neurodevelopment, and severe food insecurity, maltreatment, exposure to racial mistreatment are all recognized as something that can affect development. So people are getting double and triple whammies by being in very rough conditions, making it challenging for them to develop. And there's no doubt about that. And I've actually become more interested in looking at that on the prenatal stress side of things as well. So it is an incredibly important thing. In fact, they used to study there's a lot of studies looking at the Romanian orphans that were really, really terribly treated back in the Soviet era, and the lasting neuropsychiatric impact on those individuals was rather staggering. So it has major impacts, and we really need to get a better handle on it and learn how to optimize it. And it has a cascading effect on our society, because these individuals, the results of this impact will be lasting into adulthood, and we'll be dealing with it for the next several decades.
Yeah, thanks. And Dr. Abernathy, I know you also specialize in this area. Can you kind of, maybe following on what we heard from Dr. Eversdorf, tell us a little bit about your research studying adverse childhood experiences, and how we know these sorts of things that you experience as a child can kind of play out later in life?
Definitely. So what we've looked at primarily is what's called the Adverse Childhood Experiences Questionnaire. And so it's looking at physical abuse, sexual abuse, mental abuse, loss of a parent, really adverse type things where a mentally ill parent or a parent with substance abuse. And so what we're looking at is, does that affect the child later in life in good ways or bad ways? And what I mean by good ways is we're actually seeing it related to resiliency. And resiliency is just kind of the fact that we can keep going even when something bad has happened to us. It's related to adaptability. So we're seeing that these children that have had these adverse experiences tend to be more resilient. Now, that's not the only thing related to resiliency. You don't have to have negative experiences to see resiliency. Being involved in sports is actually related to resiliency. Spirituality and religion is related to resiliency. But we do know the more that you practice that adaptability, the more kind of better at being resilient and keep going in adverse experiences it is. So we are seeing that with children that have had these bad or negative early family lives might become more resilient. So there's kind of a positive aspect to that. They might be able to keep going in the future. But as far as brain development goes, we do see that it can impact some of the brain development early on with these adverse experiences, especially if it is things like lack of nutrition or something like that. It can wire the brain differently. And so in that case, it's even harder to overcome. So there's some positive there. We might have that personality factor of resiliency and they can keep going. But there's also this negative aspect. And a lot of that's related to other environmental factors, parenting and things like that, that can buffer, help, or hurt these factors.
If I could actually add, there's another aspect of the resilience that's of significant interest, and that's neurological resilience. If one of us were to have had a stroke that affects a large portion of one of our hemispheres, say the left hemisphere, we would have severe deficits in language. If someone has this at birth, they recover not only their language, but their motor function. The left hemisphere controls the right side of the body. I would have severe deficits controlling the right side of my body. The neurological resilience and being able to rewire is really, really quite remarkable at a very, very early age.
That is the amazing thing about early age and brain plasticity, is that they can often overcome some of these things. So although it can be so detrimental, and we talk about these negative events that a child might go through, again, that plasticity is there, so it can go good or bad. So those early events can set you up for a lot of things. We did some work looking at parenting and actually the role that fathers even play. And we see that it can change their personality, and it can actually have them have a different view of the world. Early prenatal environments are a big one there, where things can, wire the brain a certain way. The mother's stress level can change the amount of hormones, and it can wire the brain a certain way. So that plasticity is really important. But again, good and bad, just depending on all of the environmental factors and genetic factors. We can't leave those out as well.
So something to be backing off of what a lot of you all are talking about is a big issue we have right now with early childhood development is, especially in the age of COVID-19, there's been a lot of limited social interaction for children in schools, or not being able to play with friends. So, Dr. Abernathy, I think you would be a good one to touch on this. But like, what sorts of effects do we know of that things like isolation or like scary, stressful events like a pandemic can potentially affect children's brains during development?
So social isolation is a stressor, and I know a lot of you on here are stress researchers, so you're going to back that up, that stressors are cumulative, and so any stressor can impact us. Social isolation actually kind of elicits that HPA response, and we have a stress response, and chronic activation of that can be very negative and impactful. It can impact different areas of the brain, hippocampus, and different areas. What we've seen in previous research from children and from isolation and things like that is it can go on to impair some of that cognitive functioning, make them a little bit slower at cognitive functioning and things like that, simply because those areas are not used. Again, that brain plasticity in children is kind of a use it or lose it component. So if we can strengthen those connections because I'm learning socially how to interact, and this is the appropriate thing to say, or this isn't, it strengthens those connections. So when children are isolated and don't learn those type of things, then they can actually kind of have an impairment, possibly in social skills. Some cool, interesting research also looked at the importance of rough and tumble play. So those little children kind of getting together and wrestling with each other, and actually found that using this actually helped with their prefrontal cortex development. So they learned decision making and kind of when to stop and when to play and how to interact. And so what we found is that when these children did not have that rough and tumble play, their prefrontal cortex didn't develop and strengthen like it should have. And so again, not just the social isolation that we talk about with depression and anxiety, but simply that they're not getting together and even doing some of those physical things, the brain might not develop, strengthen, those synapses might not strengthen, and we might see deficits in a variety of areas. We just won't know for a number of years kind of where this is going.
Hey, Dan here popping up. I just want to remind everyone, if you have any questions or comments, type them down into the comment section below. And we actually are getting our first question in. This one in from Dr. Eleni Bickel from Facebook. And she asks, is there any evidence that depression and dementia are related? If signs of depression go untreated, is it right to say that someone is more likely to develop dementia, or is dementia caused by more genetic, have more genetic causes? That comes to us from most policy fellow, Dr. Eleni Bickel. Thank you, Dr. Bickel, for that question. And I'll go away now.
I'll take that one because I have a dementia clinic. So I'm the right guy for that one. So yes, with a couple caveats. Number one, you can have depressive pseudodementia. You can have a mild cognitive difficulty in the presence of depression. But if that occurs, you are at increased risk of developing dementia. And it kind of makes sense. If somebody is beginning to decline, but it's not yet enough to manifest, and you're to take a medicine that causes confusion in some people, you'd be the one that get the confusion. The same thing with depression. The chemical changes that occur might be enough to tip you over and cause a little bit of a cognitive impairment. That said, large epidemiological studies suggest that people who develop depression are at greater risk for developing dementia. It's a modest effect, but it is significant. The trick is we don't completely know why. It may be an issue with the inflammatory changes or the stress factors. Stress is definitely a chronic exposure to stress in midlife does increase the risk of dementia as well. So there's definitely a link there. And as far as treatment, adequate treatment presumably would be beneficial, but it does not. It's not been exactly sorted out completely in the epidemiological studies, but there is a definite epidemiological link between depression and development of dementia.
Yeah, thanks for that question, Dr. Bickle. Maybe Dr. Baker and I could follow up with you on that. I know that Alzheimer's, which is a subset of dementia, is your kind of wheelhouse. Can you back us up a little bit and maybe tell us just a little bit about what we know or don't know? I know there's kind of ongoing debate you can tell us about the underlying causes of Alzheimer's or maybe dementia more generally.
Sure. Yeah. So to sort of discriminate between dementia as a category versus Alzheimer's disease, dementia is a more general term for a cognitive decline that usually is associated with a neurodegenerative condition, and then Alzheimer's specifically has its own pathological hallmarks and can be identified for the first 100 years of our understanding of the disease by pathology. So we had to wait until an individual passed away and then look at their brain to determine if they had the hallmark lesions in the brain of Alzheimer's disease. But we have much better tools nowadays. So within the last couple of decades, there are now PET scans that have been used in research and also now in clinical settings a little bit to get an idea of what's going on pathologically in the brain prior to death. And even so here in St. Louis, there is the lab where I did my postdoctoral work at WashU. The company that spun off of that lab actually received initial approval for a blood test for Alzheimer's disease. They took basically biomarkers that they had assessed in cerebrospinal fluid, which involves obviously getting a spinal tap, and then finding out that they could use very sensitive assays to detect that even in the blood, which means that now our current picture into what's going on pathologically in disease progress is getting clearer and clearer earlier and earlier through the disease stage. And that's great news. That means that, really for the first time, we can potentially see changes happening to the pathology, whether we're manipulating the pathology with drug treatments, for example, in real time in folks, potentially even before they show symptoms. So we can identify folks who are at high risk. We can identify folks who have mutations that cause Alzheimer's disease, because there are some familial variants as well, and determine whether or not the drugs work in those populations. And then hopefully, once that's validated, bring those to the clinic and start using those in a more general population and see if it shifts the onset of time, the onset of disease to a later time point, which would already be huge, or could arrest it completely. So my recommendation to anybody who's watching this today who has ever considered getting involved in research is now is a great time. Of course, once you're vaccinated and safe and protected and have the approval of all of your healthcare providers, getting involved in trials, this current generation of experimentation that's going on is potentially going to cause fantastic breakthroughs within our lifetimes, which is fantastic news.
If I could chime in on that blood biomarker is huge. Prior to this, it had been recognized a few years ago that you really needed to have separate out dementia from Alzheimer's quite distinctly, and you can have Alzheimer's disease without dementia. You can have all the biomarkers and the pathology of Alzheimer's disease, but you're preclinical. Unfortunately, the ways to do that involved either a spinal tap to look for the breakdown products of related Alzheimer's disease, or a PET scan. A spinal tap is invasive, and the lab tests are sometimes expensive, depending on your insurance. And a PET scan is nuclear medicine, so it's a radioactive compound, and it's also terribly expensive. And so neither of those were a trivial thing to do. As it happens, we didn't have any treatments that were terribly specific. You had a couple of drugs that were targeted to Alzheimer's disease, but it didn't matter that much whether if you gave it to somebody who had something that wasn't exactly Alzheimer's, you'd probably try the same drug anyway. They've all gone generic, I believe, at this point, so it wouldn't be expensive to give that a trial. However, there are new drugs that are coming down the pipeline, maybe become approved, that are very specifically targeted to the pathology of Alzheimer's disease. Instead of just tweaking some neurotransmitter, they're targeting the pathological features of Alzheimer's, excuse me. And so you will want to be able to make that diagnosis, and having a blood test that can help us do that, as opposed to a spinal tap or a PET scan, is a huge advantage. And I would like to thank you for helping bring that to the table.
So I wanted to bring in some of our other guests here to talk a little bit about a topic that's near and dear to my heart is substance use disorder research. So for Dr. Rodnick, I wanted to ask a little bit about over these last few years. I think everyone who's watching this has probably heard at some point on the news about this opioid crisis that our country is currently in and has been for many years. So could you tell us a little bit about how substance use disorders are defined and what kinds of substance use disorders are common, and also especially here in Missouri about how Missourians are being affected by this?
Certainly. It's a pleasure being here today. I feel like we're going from the sacred to the profane a little bit with me, but four major buckets of definitions that the DSM-5 considers for substance use disorders for today. And those four areas is that when does use become a problem? Loss of control of how much I would use of a substance. 2, does use of a substance impact my relationship with others? 3, do I continue to use regardless of how risky the use is? And number 4, are there changes in my body, dependence and tolerance? Opioid use disorder is sucking all the air out of the room right now in the United States because, in particular, the introduction of the synthetics like fentanyl and carfentanil and iso and all these other substances that have potency milligram for milligram 50 to 5,000 times what prescription morphine is. Due to the business model of illicit drugs, it's much cheaper and easier to do serial cutting of a high potency opioid like fentanyl. Due to that cutting process, which usually isn't done in the kind of labs that most of us are used to, the potency creates it can be very irregular, which is why somebody experimenting with drugs or even a longtime user of drugs can use a drug they think of what is one potency and ends up being much higher. As a result, and then couple on top of that, challenges we've had due to COVID-19, where we see increased isolation, increased job insecurity, financial insecurity, housing insecurity, and lots of other insecurities. We've seen that numbers have gone way up when we were starting to see some decrease in the number of opioid overdoses. It's estimated that in the last 12 months, over 88,000 people have died from an opioid-containing overdose. And these are conservative numbers because that's mean when people die, they're tested, toxicology reports are done, and we have answers. In less resource communities, that's not always the case. Now, I say opioids have taken a lot of the air out of the room. We need to remember, though, that about 95,000 people die every year from alcohol-related use disorder. It's just usually not as fast and not as dramatic. And almost 500,000 people, another order of magnitude, die from tobacco-related use disorders. What we're seeing in Missouri is we are in kind of a north-south channel where we're seeing still seeing a lot of the predominance of opioid use disorder as the most profound public health challenge. But west of us, including Kansas City on west, it's in many communities, it's a methamphetamine use disorder challenge. So how this ties in today's discussion is really interesting because there's a lot of similarities to how our brain works with chronic opioid use disorder and how our brain works with chronic trauma and toxic stress. Essentially, the forebrain and the prefrontal cortex kind of loses communication with the brainstem. My buddies in trauma, and I like to call that the lizard brain and the wizard brain. When those two don't communicate well, lizard brain wins. Our urges, our cravings, our need to be alive, our need to use often predominate and drive our behaviors. So when we talk about a medication first model for opioid use disorder, we're talking about using medications that can help our neurotransmitters calm down and to allow our brain to heal.
Yeah, thank you so much for that. And Dr. Buchanan, I'd like to bring you in as well. So your research focuses a lot on stress and decision making, but also a lot about how this can overlap with substance use disorders. So can you tell us a little bit about how stress can affect the brain? I think we're having trouble hearing you. I don't think I can hear you, Tony. Well, while we're waiting on Dr. Buchanan, Dr. Rodnick, would you like to touch a little bit on about, you talked about how we have this major issue in the state of Missouri, but also what are some promising interventions that are coming up in the pipeline?
Sure. I wouldn't say nothing's really new in this area. We have 5 FDA approved medications. 3 work with OUD, 3 work with opioid use disorder, 3 work with alcohol use disorder. I would say the most promising trends we've seen in Missouri is a willingness to look at harm reduction, including naloxone or Narcan distribution, which reverses opioid use disorder, a willingness to fund that and use that to help keep people alive until they're ready to engage in treatment. And then, of course, the other piece is the treatment for alcohol. Sadly, we have no other FDA-approved medications for methamphetamine use, benzodependence, et cetera. The most promising thing in this field that I know that we're looking at right now is telehealth and use of that. And hopefully we will not snap back to pre-pandemic guidelines on limitation of virtual care. Virtual care has been a huge step forward in connecting with people who need these resources. The other piece is, I know at St. Louis University, one of my colleagues, Daniela Salvemini, her whole area of research is looking at non-addictive analgesics. And she's looking at these on a cellular level. How do we understand better the pain signals and how we can interrupt some of those, particularly when it comes to cancer and, we'll just say cancer, it's easier to say on a Friday, how that interrupts pain cycles, but in ways that are not addictive. We really have done a disservice to our society for the last 50 years in not doing innovation around substance use disorder, and also falling for the false tales of the fact that if you're in pain, you don't get addicted to opioids. So we really need to engage more fully and robustly into new interventions, non-narcotic interventions, and quite honestly, non-medication interventions when we're talking about treating pain, particularly chronic pain.
If I could take the opportunity to ask Dr. Dr. Buchanan's back. Can we hear you now?
I don't know. Let's see. Can you hear me?
Hey.
All right. Well, I'll finish my thought then. I apologize for my technical difficulties. The paradox of stress and addiction is one in which people who have a substance use disorders often will refer back to a stressful time in their life as something that either caused them to initiate substance abuse or to relapse into substance abuse. And yet what we see when we look at the stress physiology in people with addiction or at risk for addiction is that they show a blunted stress response to stress in general, to stress in our laboratories. And so it seems as if the stress system is less in tune, the stress physiology is less in tune with what's going on in the outside world, and they need more stimulation in order to get their nervous system going than the rest of us that perhaps are not addicted to substance. And so that's one of the challenges that our lab is interested in, is what is it about the nervous system of those who become addicted that makes them less reactive to stress at a physiological level, and yet then makes them more sensitive to the development of addictive disorders going forward.
Tony, is that thought to be compensatory, or does that pre-exist? Does that predate the addiction development?
It pre-exists prior to the addiction. So there's been a long series of studies called the Family Patterns of Addiction Studies out of Oklahoma. And what they find is that people just at risk for addiction through family risk of addiction due to parents who have substance use disorders, but the offspring haven't shown any addictive behaviors themselves. They show a lack of a stress responsivity, suggesting that it predates the development of the addiction.
Thanks, Ed. Yeah, no, go ahead.
There's some cool research on that on video game addiction as well. Like that's the newer area with media, social media, and video game addiction, and showing that there could be, again, that kind of, it's like they believe it might be a genetic link to addiction, and then it's something they might be related to personality traits and sensation seeking, and they have a blunted cortisol response, and so it takes more to arouse them, and they might get it from that instead of a chemical drug, but it's its own drug, right? So there's some cool stuff on video games now. So
yeah, we've done some work on another behavioral addiction, gambling disorder, and we found similar patterns in that population as well. So gambling disorder we think it's similar in many ways in terms of the development of the addiction.
Thanks for that. Dr. Buchanan, maybe I'll stay with you for 1 second here. So I think colloquially, I sort of know what I mean when someone tells me that, they're feeling stressed, or if I tell someone I'm feeling stressed. As a scientist, what does that look like for you in the laboratory? What do you mean when you talk about stress? How do you measure it? How do we know what it does? Can you tell us a little bit about the kind of scientific perspective on stress?
Yeah, that's a great question. It's one of those challenges for what is colloquially termed as stress versus what we mean and when we talk about stress in the laboratory. The way that we conceptualize stress in the lab is an event that poses a challenge to your well-being that you perceive as being uncontrollable and that elicits negative emotion. So if the important part of this is it's the perception of those events. And so if I break my arm, I perceive that as being an inconvenience. It's not something that I would sign up for. But if it were an Olympic athlete who broke their arm prior to the Olympics, for instance, that would be a devastating. So it would be a challenge to their well-being. Their well-being determines on using their body to excel. It would be uncontrollable. They have no control over the situation anymore, and that they experience negative emotion from that. So it just so happens that those are the three characteristics that elicit a cortisol stress response in our bodies. And so we sort of use cortisol response in the laboratory as a proxy for some of those experiences of stress that we see. Now, importantly, just like I said, so just because something is stressful to one person doesn't mean it's not stressful to another. And the discussion we heard earlier about resilience is one of the key factors relating to that. Just as there's individual differences in what we perceive as stressful, there's individual differences in how resilient people are to those stressors.
That's really cool. I'd like to ask either of you, Dr. Rodnick might be the one for this, but I keep hearing interesting things about LSD, microdosing, and MDMA in addiction, which is rather ironic. You're using one controlled substance to treat another. And that the data is really intriguing, very promising. And there's two issues. One, how's the data looking for that? And two, wow, could you ever even use it because it's so tightly regulated? That is it ever gonna? It'd have to be pretty gosh darn amazing for that stuff to come down to have an impact in order for those rules to change. I'd love to hear your the story on that because it's a hot area of research, I know.
Sure. First of all, we need to move cannabis out of a Schedule I drug so we can actually do some research around it. But that's kind of a good intro to this because with other substances out there, whether psilocybin, whether MDMA, whether other items. It's worth taking a look at. The problem is that most of what we have now is anecdotal or done somewhere else. There are 2 sites in the US, for example, where you can do the psilocybin research, and that's at NYU and at Johns Hopkins. And the way I kind of describe that, though I do have Michael Pollan's book on my bookshelf to read right now, talking about how to change your mind, where he did a deep dive into mushrooms. We know that there are advantages and good applications for using ECT, electroconvulsive therapy, that has changed over time. We know that there are useful advantages for using transcranial magnetic stimulation now. That's a very new field as well, but it's also being used for recalcitrant depression and other issues. What I kind of think of with some of these things like psilocybin, mescaline, other hallucinogenics, again, this is the Dr. Fred version of it. I almost see them as those being the chemical versions of a reset, like electricity can do, like magnetic pulsing can do, and now chemical pulsing can do. I'm fascinated to see what can be done with this. Right now, the only studies that have been done is under direct, I don't want to even say supervision, direct observation of a physician, because people can still have bad trips, people can have unpredictable outcomes. But the interesting, again, the few studies that I've read with hallucinogenics is that they work best in conjunction with a medical physician as well as a therapist who can do guided imagery and guided studies, particularly with folks who've experienced trauma and PTSD. How I've heard it described is that it's almost the disembodying feature of these drugs allows someone to see themselves and detach from the negative emotions that have been associated with the traumatic events. So I'm game to see what happens. I hope that people do more studies in this area, because if we don't do something around this, we're going to have more people trying to do things on their own, because we know mental health and chronic pain and substance use disorders have typically not been treated well in the US, and that is even worse with people who don't have resources. Hopefully that answered a bit of your question.
Very much so. Thank you.
Great. I want to take this opportunity to remind anyone watching here, drop your questions in the chat wherever you're watching, while we've got this great panel of researchers. And then I also, while we're on this sort of positive note here, talking about potential developments, new developments, I wanted to open it up to showcase the great research that we've got going on in the state of Missouri, and just open up if anyone has anything they're particularly excited about in their own research or in their field right now that is really promising or cutting edge that they want to share with us. I'd be happy to hear, and I know our audience would be happy to hear about that as well.
So I've already made my pitch for folks enrolling in Alzheimer's disease studies right now. And I know it's not Missouri, but we're really just a short day trip away from Chicago. And I did my graduate research at Northwestern, where there's a really great Alzheimer's Disease Center, which is the home of the Super Aging Project. And that is, you know, if we're moving from sort of negative to positive on what possibilities we might have in terms of stress, there's also movement in that in Alzheimer's as well that sort of parallels very nicely, in that there are people out there who in their 80s and 90s perform in cognitive testing equivalent to folks in their 50s or 60s, and seem to be resistant to neurodegeneration. And again, the idea is, well, gee, let's bottle that and give it to everybody, right? So if anybody watching this knows of family members or friends who might qualify for that line of research, I strongly recommend seeing about getting qualified and enrolling, because it's just really cool work. For one, Dr. Rogalski at Northwestern is in charge of that. And it's just, I've been watching that project because it started while I was there as a student, and it's just grown, and they've come out with some really good papers since then. And we've also gotten, in Alzheimer's disease in the last few years, we've started to recognize genetic mutations that are preventative, that are actually protective for developing the disease. And all of those are very good signs, right? They show that the human physiological system has the capacity to be resistant to this terrifying illness. And now it's just up to the scientists to really dive in and figure out what's really going on there, and is it something that we can then provide for the rest of us to keep us safe and healthy into the end of our lives.
I find all the researchers on this call, I find the research encouraging because I'm more of a clinician and an educator, but I do know that in the past, when we did not operationalize this idea of trauma and how trauma manifests, we've done a lot of really bad treatment. Whether it's treating kids who have experienced trauma for ADHD or schizophrenia, which we have done, or whether we've incarcerated folks rather than looking at the root causes of behavior. And it encourages me so much to see all these different areas, because when we've missed trauma and we've missed brain development and we've missed what is a baseline of normal, we've not done good work by our folks. And in the US, when we kind of mistreat, too often mistreating means over-medicating, and no one wins. And we create more stigma because we're not successful, and we blame the patient. So thank you very much for this work. It's exciting.
We're looking at some stuff now that kind of overlaps with that cortisol and the stress response. And what we're looking at is these adverse traumas. Basically, does it kind of desensitize you? Is that related to the resiliency? And so we're looking at skin conductance, and we're looking at, which would be your physiological response, kind of stress, or even empathy. We're looking at it related to empathy as well. And so when you see these adverse experiences, if you watch a film about it, if you're told about it, do you have a blunted response? Are you not responding, or a heightened response if you've had it in the past? And then how's that related to resiliency? So we can really get at what is kind of developed with these individuals that have had these bad experiences. Kind of goes into things like PTSD. So it's all overlapping with what we've been talking about. So we're trying to see if it's really changed their overall physiological response for future events based on past, again, using saliva, cortisol, and skin conductance.
I'll follow up that because of this the stress piece. We've just recently published a paper looking at using a controlled stress task where you have them do difficult math problems that are geared to be a little too difficult for them while they're in the scanner, and then we'd interrupt them and have them do verbal problem-solving tasks. And we look and see what connectivity patterns are associated with the effects of stress on cognition. Now, what we want to do with that, we looked at genetic susceptibility to stress along with that. What we want to do now is look at patient populations, people with anxiety disorders or PTSD, and see if they have an outsized effect of stress, what that's doing in the brain. And that may actually be an important marker for response to treatment in these individuals. This may be something going on in their life to see if the effects of their ability to solve problems is something that is a major factor that's been untapped. But in the meantime, that has led us to do the trial I briefly mentioned. We're taking a blood pressure drug, propranolol. It's actually the same drug that you take for test anxiety. It's designed initially to control heart rate and blood pressure. But the beauty of doing a repurposed drug in a study is that you're avoiding the exceedingly high cost of a new drug, and you're also avoiding having to go through a decade of the FDA approval process for something that people can get for dirt cheap already. And so we looked at it, and we're already beginning to show a significant positive effect on anxiety. But one of the tricks with autism, two tricks with autism. One, there's many different biological contributors, a whole bunch of different genes, some prenatal environmental factors as well. And so every case is a little bit biologically different, and everybody responds differently to the medications. So you have to have biomarkers, and we're looking for biomarkers of increased arousal. That's still being analyzed to see if they predict who responds. And also they have a tremendous placebo response. People who enter a trial on autism do better over the trial, as I think, because the survey questions they'll tend to answer more favorably because they're kind of hoping for an effect, and so you have to have a stronger effect than you have the placebo response, which has tanked some trials in the past, and so the biomarkers can help answer those questions too. But that's all right here in University of Missouri, and we're really excited about those prospects for the future.
Dr. Eversdorf, I hope your patients are appropriately remunerated for having to be in a scanner doing 2 hard math problems to participate in your study. That sounds particularly torturous.
It is, but these are not the individuals on the autism spectrum. These are the volunteer college students, so it's not so bad. We do have.
They all get extra credit, right?
Well, actually, no, they get paid. They do get paid. It's an imaging study. We won't have them just do it for extra credits. It's kind of a pain in the tuchus. But the autism study, we did use imaging biomarkers, but just as a predictive marker, no stressor.
But you're building resilience in the college students, so that's wonderful.
My lab is known for doing all kinds of stressors, and we have done the Trier social stress test with the math portion and an interview portion, and then we went on to lie to them and reject them and told them everybody was doing better than they were and things like that. So we do a lot of images. We've had people throw up. It's really, we're building resilience. I'm gonna put that out every time that I do a research project now, is I am building resilience in you when I debrief you at the end.
The Trier, actually, the MIST is what we use in the scanner. It's basically the imaging version of the Trier. To pivot to the Alzheimer's side of things, we're doing a study with soldiers doing breacher training at Fort Leonard Wood right now, and those are the ones that are standing behind the shield trying to breach a building, so they're exposed to blasts, beginning to look at the amyloid in the brain with PET scans, and it suggests there's something there. Even in a young 30-year-old that gets exposure to that. But the question is it transient? And is it something that with rest and recovery will go away or not? And that's not known yet, but that's really, really important to know. And it doesn't generalize to other TBI. That's not really been looked at before.
I'll throw in one new thing that we've been doing in our lab. It's not new to science in general, but another way to measure stress cortisol that we've started collecting is hair samples. And so your hair grows at about a centimeter a month for some of us, and then you can cortisol gets taken up into the hair follicle at that time period. And so if you get a length of hair from a person about 2 or 3 centimeters long, you can sort of work retroactively and see how much cortisol has been released during that time. And so it's sort of like a tree ring of stress of someone's life during that time. And so we've been, because we're not able to have people in the lab right now, we've been starting up a project in which we'll be collecting hair samples that they can collect in their own homes and bring it to the lab, and we can get a sense of their cumulative stress exposure over the past 2 or 3 months.
I guess I can't participate.
We might be able to use your beard.
You asked me earlier about social isolation, and one thing that we were actually looking at now is parasocial relationships, and it's odd, but it's a relationship that people have with celebrities. It's a one-sided pseudo relationship. And we're looking at it, and we've actually found it related to subthreshold autism traits. So those that would not be diagnosed with autism, but often are related or genetically, and they might have social skills deficit. But we're actually taking saliva samples to look at oxytocin, to see if they're bonding. We have them watch 20 minutes of their favorite celebrity and look at oxytocin before and after to see if they're actually having that bonding experience. So I started it before COVID, but COVID was a good time for it because a lot of people, we have Zoom now, right? So are we bonding now that you see me? And is that happening with celebrities? And so we're looking at it related to personality and related to subthreshold autism traits. And then oxytocin's a newer area we're looking into as well.
I wonder if there would be fruitful ground for that with very loyal podcast listeners who spend many, many hours listening to the same personalities. Huh.
So they were allowed to choose their celebrity, and then we categorized the celebrities. And so we had to go in and then find 20-minute clips with celebrities and things like that. And so it's been interesting to see. It's college sample. We've had like 12 Taylor Swifts.
Wow, thanks for that. Well, as the pandemic wraps up here, I'm sure, Dr. Buchanan, you'd have no shortage of cortisol in any of our hair samples if you were to take them now. And I'm sure we can all, in the social hour after this, talk about the one-way virtual relationships that we've formed throughout this. So maybe as we wrap up here, I can throw it back to Dan English. Dan, if you want to do one more round of advertising for us maybe here in case people missed the early round, and tell us about what's going on after this event comes to a close.
Absolutely. You know what? I'm going to invite everyone to our social gathering. I call them after parties after this. It's just a chance for you to ask questions to all of our researchers here. Of course, to all of our researchers, you're welcome, but it is Friday afternoon. You don't have to join us at the risk of doing something that I shouldn't do. Boom, there it goes. There's the link to it right into the chat. So anybody can click on it. Feel free to do so. Again, before we back out of here, I do want to remind everybody of our Science and the Law event. You can learn how science can be used in the judicial system and learn what it takes to be an expert witness. We're also going to talk a little bit about what it's like to be on the stand as a witness in front of the legislature. Our most fellows have a lot of experience doing that. You can find this, just head to mostpolicyinitiative.org. Click on the Local Science Engagement Network tab. There's a drop-down menu, and then you can find our live event from there. It's pretty easy. There's a lot of talk about, who's going to be plucking whose hair, and you're not getting any more of this. I can't spare anymore. So thank you. I always feel like I cut these off right at the wrong minute. I mean, we only budget an hour for these things, and we're running up against time. Thank you for everybody for showing up. We have about a minute left. Does anybody have anything, any burning question they want to add, or any kind of comment they would like to leave us with?
Well, maybe while we're all on here, I'd like to thank Hannah for joining us today. Hannah, I think, is handing in final copy or almost final copy of dissertation after this meeting. Congrats.
Yes, after this meeting, I just have to update my table of contents and get it in.
Congratulations, Hannah. That's really impressive.
Congratulations, yeah.
Great.
All right. I guess we'll cut it off here about 20 seconds short. Remember, if you want to join us on Zoom, I put that link in the chat. Take yourself 5 minutes, go grab your favorite beverage, and we'll go as long as the Zoom lasts. 5 minutes, 15 minutes, an hour, whatever it takes. We'll see you there. Thank you, everybody, and I hope to see you on the flip side.
Bye-bye.
Thanks, everyone.